today's problem today. So in the question you are given an array nums and you have to perform queries on it. Okay, so what are the queries? Every query consists of two integers from I to I. Okay, so which represents a subarray in the nums. So let's see, like in the example, here the first query is 0 to 2. So it represents the subarray from nums from 0 to 2 indices, that is 431. So for every query you have to return like you have to check that whether that subarray is special or not. So like here you have to check whether 431 is special or not. If it is special, then return true. If it is not, then at that index return false. Likewise, like for 2 to 3 subarray, so from index 2, which is this 1 and 6, index 2 to 3, you have to check whether this subarray is special or not. If it is special, return true. If it is not, then return false. So you have to return an answer array. Okay, you have to return an answer array which represents answer of I represents the answer for that particular query. Now what does special means? How an array can be special? An array can be special if there is no adjacent elements uh, of different parity. Okay, so if an array is considered special, so the array is considered special if all the elements in the array, all the adjacent elements in the array are having different parity. So basically what does it means, like 3 and 4. So parity means like different odd and even. So the adjacent elements should have different parity. So like 3 is odd and 4 is even. So these both are adjacent and they are having different parity. Likewise 4 1 is also even and odd, then 1 2 is also odd even. But now 2 and 6 both are even, so they are not of different parity. So therefore if any single element, a single pair consists of like if the same parity is there of any single element, any single pair in the array, then in the subarray, then you have to return false. If all are having different parities in the adjacent elements, then you have to return true for that subarray. Okay, so what I thought of this question is what we can do is we can check in, like pre-compute that at which indices the parities are seen. So like in this example, I will make an array list and I will store the index of these last two indices. That these last two indices are the indices in which the parity is seen. So if any of the query which will consist of these last two indices, I will make that like answer for it will be false. And if these are not there in that subarray, then uh, the answer for it will be true. So likewise, like in if we see this example, so here 4 3 is different parity, 3 1 is same parity. Okay, so in an array list I will track all the indices, pair of indices which are having same parity. And if any query consists of any of those indices which are having same parity, I will just return false for that particular subarray, or else true. And obviously we can't apply brute force n square because it will go n square, which will not get accept. So uh, like what I have done is I am pre-computing the indices where the parity is same. So this is the condition, like you can do you can check by another method also, but I have checked by this method. If the sum of those elements, adjacent elements, is uh, even, then it means that the parity is same. Okay, so I am adding the array in the list, I am adding those indices. So this array list contains all the pair of indices which are of same parity. Now if any of the query contains these indices, then the answer for them will be false. So to process it very efficiently, what I have done is we have to I need to sort the array, the queries array, so that then I can take a pointer on this array also, and then move it accordingly. Uh, so uh, yeah, but I can't sort because in the answer array you have to return like in the order. The order can't be changed of the answer. Okay, so what I have done instead, I will sort, but what I will do first, I will store all the indices, the original indices of the elements in this hash map of the queries in the hash map, and then I will sort it. So therefore I have made a pair thing, okay, object which will like now the which pair will store query. Okay, so and yeah, so x is start and y is end, every pair which represents a query, and I am putting the index, current index of it in the map of the current pair. Okay, and then I am sorting the pairs. Okay, now I will this is the pointer which is pointing to this array list. Okay, which contains the elements which are having same parity, pairs which are having same parity. So yeah, and this is the answer which I am going to return. So what I will do, I will traverse in the whole queries, all traverse through all the queries, and I have I have here taken the start and the end point of the current query. Okay, now uh, now what I will do, uh, until like the the current pointer start, okay, uh, is less than the end of the current query, I will just increase. Okay, I will move to the next point because I want the uh, element which is greater than start and which is less than it. Okay, so whenever I will get it, I will just break it. Okay, and if break it, and as I have got the element of the same parity, then I will just make the flag false and the answer for that will be false. But if I didn't get anything, and between this start to end, and the pointer of that array, the parity array, which contains the same parity elements, if that goes beyond the end of the current query, then obviously we can't get it. So we will can't get the elements because the all the same parity elements will be greater than n only. So it will be not in the range, and therefore for that answer will be true. So initially I have initialized it to true. If it changes to false, then yeah, then the answer will be false, else it will be true only. And yeah, to get the original index of the uh, current element, which is pairs of I will take it from map because I have sorted it. Therefore the indices are also indices have also changed. Okay, yeah, at the last I will return the answer. Let's try to submit it. Okay, yeah, it's getting accepted. Okay. Thank you for watching.